Uh-huh. Uh-huh. Hello. Hello. Yes sir, yes sir. இல்லை சார், பேட்டர்ன் டிராஃப்டிங்லேயே நம்ம 2 நடத்தியிருந்தோம். பேட்டர்ன் செர்ச் அண்ட் டிராஃப்டிங் ஒன்று, இப்போ அடிச்சிருக்கிறது வந்து பேட்டர்ன் டிராஃப்டிங் டூஸ் அண்ட் டோன்ட்ஸு. இது வந்து ஆஃப்லைனில் நடந்த இது வந்து நம்ம காலேஜில் வச்சு நடத்துகிறோம் சார். ஆல்ரெடி போட்டது வந்து ஆன்லைனில் நடந்தது சார். ஓகே சார், ஓகே சார், ஓகே. தேங்க்யூ சார், தேங்க்யூ.
Jalishman? Jalishman?
Afternoon, sir.
Shall we start?
Yeah, yes, sir. We can start, sir.
Does no participants that I call upon Jalishman ma'am to the lecture on the hands-on session in the Google Colab related to the Python packages like Pandas, Numpy, and etc., which are not going to be used for the next 4-day session. Ma'am, please. Now I hand over the chance to ma'am.
Yeah. Okay, sir. Thank you, sir. Good afternoon to all. I am B. Vijayalakshmi, working as an assistant professor, senior grade in the Department of Computer Science and Engineering, Ramco Institute of Technology, Rajapalayam. In this session, we are going to see, sir.
Okay.
So in this session, we are going to see the basics of Python and Python packages, which are essential for the machine learning process. Okay. So we will start with the basics of Python because here we are having the participants from all the domain. So we will start with the basic introduction of Python. After that, we will go with the Python packages necessary for the machine learning process. Okay. So is my screen visible to everyone?
Yes, ma'am. Yes, ma'am.
Okay, sir. Thank you, sir. So, uh, thank you, sir. So, this is the content we are going to see. We start with the basics of Python. And after that, we have to discuss about these three packages, Numpy, Pandas, and Scikit-learn. These three packages we are going to discuss in detail. Okay. So, first we will start with this Python basics. So, as most of us know, Python is one of the high-level object-oriented programming language, and it is an interpreted language. It is not for a particular application. It is a general purpose language.
Ma'am,
Sir?
ma'am,
Sir?
your voice is not audible.
Yeah, 1 second, sir. So now it is okay, sir?
Yes, ma'am. Yes.
Okay, sir. So as we know, Python is one of the high-level programming language. It is a general purpose language. We can have n number of applications for Python. I have listed some of the few. It is for web development, scientific and mathematical computing, and we can design this graphical user interface using this packages. So Python having n number of packages available with this. With the help of these packages, we can do any applications with this. Okay. So this is just introduction for Python. And now we are having the hands-on session with this Google Colab. So Google Colab is a free Jupyter notebook environment that runs entirely in the cloud. So no need to install all the packages and everything we need in our system. We can directly use this Google Colab. This is the link to access the Colab. I just post here in the chat box. All of you can open this Google Colab. We will have a hands-on session for all the things what we have discussed today. This is the link. You can access this Google Colab from this link. So before going into that, I will just share some of the things about this Python. Those who are new to Python, you can just learn this. Those who are all familiar with this, you can just listen. What is the thing? Because the participants may come from various streams, so we need to just give a basic glance for this Python. So Python is an interpreted language, so there is no need to write an n number of lines to print a single statement. So for example, we can just give a statement like print. Within double quotes, you can specify the things what you want to print. So print within double quotes, you can give this line to print the particular statement. Welcome to Python will get displayed. Suppose if you want to do some addition of two numbers, it is like our calculator. So we can assign the value for A and B, and we can calculate C is equal to A plus B. And if you write print of C, you can get the answer as it is. Okay. So this is just basic things about Python. And when you come with this machine learning operations and all the things, we have to be familiar with this Python data structures. That is list, tuple, dictionary, and set. So these are the four major data structures used with Python. So first thing is a list. List is a collection of ordered elements. Okay. That is, we can have the elements surrounded by the square bracket. How to declare a list is list name that is equal to within square bracket we have to specify the set of elements. So and one more thing, main thing about list is it is a mutable one. So what is the meaning of mutable in the sense? Once we can define the list, we can able to modify the content. If you want to suppose if you give one number as wrong, then you can edit the content in the list. That is the thing, meaning of this mutable, that is changeable. Okay. And the second I will give the hands-on session for all the things. Now I just brief what are all the data structures available with Python. And the second thing is tuple. So tuple is it is also an ordered collection of elements. It is denoted within the parenthesis. Okay, that is tuple T1 is equal to within parenthesis we have to specify the set of elements. And one more major difference between list and tuple is immutable. That is, you cannot able to change the elements present in the tuple once you define. For example, if I am giving the third number as 22, suppose if I want to modify, in that case, you cannot able to edit it. So once again, you need to create a separate tuple. In that tuple only, you have to change the value and store it away. That is the difference between list and tuple. Okay. And the third one is the dictionary. So dictionary is a key value pair. It is a collection of key value pair. So the dictionary is enclosed within this curly braces. So dictionary equal to, within curly brace, we have to write key followed by value, comma, key followed by value. So example given here, dictionary D1 is equal to name, VG, and roll number is 30. So here name and roll number both are represented as key, and VG 30 is given as values. Okay. So here the key should be as mutable. Sorry, values are mutable and the key is an immutable. Okay. So suppose you can give the key as a string or any data type you can specify, integer, float, or string, anything you can specify this key. And similarly, if value is a string, you have to give with it single quotes or double quotes. You can use any one. And the last one data structure is set. So set is an unordered collection. Okay, there is no specific ordering. It is also declared within the curly braces. You can specify. It is just like a list. Okay, but you have to specify within curly braces. But the difference between list and set is, in set you cannot access the element based on index. There is no indexing. So in the case of list, we can get the elements based on the index. Index in the sense position. So for example, the element 1 is present in position 0. Index start from 0. So the first element is present in the position 0. Number 3 is present in position 1. Number 4 is present in number 2. Like and so on we can give. But in the case of set, you cannot able to access the element based on indexing. Okay, and one more thing, set does not allow duplicate values. Suppose in a list you can give any number of 1, any number of 20. The same numbers can be repeated a number of times. But in the set, you cannot give duplicate values. It will not allow duplicate values. Okay, so these are the 4 major data structures you should be familiar with for machine learning. Okay, and now we will have some few hands-on experiments for this basic data structure. Okay, so I will share my Google Colab sheet. You can all open your Google Colab sheet. I will do it. So I hope all of you have get this page when you are opening your Google Colab for the first time. So here you can see this is the available examples in this Colab. These are the pre-built examples, and in this recent tab, if you have opened some of the files, it will be listed here. And if you want to open a Python file from Google Drive, you can take from this tab. Suppose in your drive you have some files, then you can access it from this tab. Okay, suppose you can get your data from GitHub, that is also possible. You have to give the GitHub URL or ID here, and you can search and take the data. Or else if you want to upload a fresh file, you can also do that. So for example, if you want to give, you can click choose file and you can take the file from your desktop or laptop. Okay, so from these things you can get. So for example, now I'm having this sheet. So suppose if you want to so you can take a file to new notebook. You will get an empty notebook like this. So this is the Jupyter notebook. This is launched in cloud. In this Google Colab, there is no need to install any packages. Suppose if you are having Python in your machine, either you can have Python ideally or Anaconda. In that, if you want to import this machine learning packages, you need to install. Okay, so you have to give a specific command called pip install and your package name. But in this Google Colab environment, there is no need of this installation anything. Everything is available. If you want, you can just use this command called import. import and corresponding package name if you give, it is imported to this notebook. Okay, that is one of the advantage of this. And you can see this is we are having two types of cells here. One is code cell and another one is text cell. You can see here, this is plus code and this is text. So text is just for giving information like this. If you click this text, you can see this is again. You can type like this, basics of Python I am giving here. Suppose if you want to make it as a bold, you can do it with the help of this B. So after just click this, just click enter, you can see this is the text cell. In this text cell, you cannot edit, you cannot execute the code. So if you want to execute your code, you have to create a code cell. So you can see the difference with this code cell. So in this code cell, you are having this small arrow. This indicates that you can execute this cell. For example, so just if you want to print a message, you can just give this print within double quotes. You can write this. Just you can click this arrow, the code will get executed. So when you are seeing this, you can see here. So in this place, you can see it is connecting, initializing. First thing it will comes with allocating. So the resources are allocated to you. After that, it is connected to the remote system. After that, you can see like this, the environment is connected. This is the RAM usage and disk. Okay. So in this, you can have this local runtime and this thing. If you connect it, it will connect it to this hosted runtime. It is connected automatically. Okay. So just you can click this button to execute your code, or else you can press Control plus Enter. You can see the message here. If you click Control and Enter, it is also executed. Okay. So in this, you can see one number. So for each cell, it will have some number 1, 2, 3 like that. So what is the meaning of this number is it indicates what is the ordering of this execution of this cell. For example, if I am typing another one message, so and I am executing this, you can see the number is 3. So you can see the number 3, that is, it is executed after this cell. We can identify in which order the cells are executed. We can see that with the help of these numbers. Okay. Within the same cell also you can do any operations. That is also not problem. For example, if you are saying A equal to 10 and B is equal to some 20, and we can take C is equal to just A plus B, and if you print C, you can get the results. So welcome is based on this line and C 30 value is printed based on A plus B. Okay. So suppose if you want to print some message along with this, that is result is like this. If you want to add, you can write result is, it should be within double quotes. Whatever you give within double quotes, that will be print as it is. Okay, so you have to put comma, after that C. Now you can see the result is as it is printed. In the C, we are not giving double quotes. So automatically it will take the value of C as 30. Based on the calculation, it will display the value as 30. Okay, this is the very basic things, and we can find out the type of data. So for example, if I am giving this 20 as 20.5, so obviously it is of type float. So you can check with this function called type. So type of A. If I am giving like this, I can see what is the type of this A. You can see it is a class int. It is of integer class. And similarly, you can see print of type of B. So you can see B is of type float. Similarly, we can have some string type also. Some S is equal to. If you give, you can check it with this type. You see this is a type string, str class. Okay, so this is the way you can find what is the data type of a particular variable. Okay, so I will have some few functions with this. You can see these are some of the functions with list. Okay, so at first I'm giving this list is declared as some value. Okay, so we can use the function call. So we can have n number of methods with this list. Okay, so some of the functions are sort and append, remove, count, pop, reverse, and these are some of the functions I have given here, methods I have given here. So what is the use of this sort function is it will sort the given list. Automatically it will sort in ascending order. Okay, so append function is mainly used to insert an element into the list. That is already I told list is a mutable one. That is we can edit, we can delete, we can insert new element, or we can modify anything we can do with this list. So append function will add the element at the end of the list. Okay, so now I can see what is the output till this. You can see this is the initial list 10, 23. After sorting, you can print this. It is in a sorted order. Okay, so I'm adding another one element called 10. So you can see the output is the 10 is appended at the end. Okay, so and we are having some more functions. So another function is count. So this count function is used to count the number of occurrence of a particular element. Okay, so here you can see 10 is present 2 times. So I can find out the count, how many times 10 is present in the given list. Okay, and another function called list.remove. So this will remove the particular element from the list. Suppose we are having 10. You can see here 10 is in this place, also in this place. Suppose if I am giving remove function, it will delete the first occurrence of the given value. That is, this 10 gets deleted. Okay, so and similarly another one deletion function is that pop. So this pop is used to remove the element at a particular index. That is the element at index 3 that will be deleted. So remove function is for deleting the element. Okay, so pop function is used to delete the element at a particular index value. Okay, and next function is reverse. So this reverse function is used to just rearrange the elements from last to first. It will take the elements. Okay, and if you want to modify an element, for example, suppose in this first location the element is 6. If I want to modify this into 100, then I can directly use this indexing list 1 of index value 1 that is equal to 100. You can specify. Okay, so now I just execute remaining things also. You can see this count function will return the value as 2 because 10 is present 2 times. Okay, so after removing, you see the first occurrence of 10 gets removed. So all the last occurrence of 10 is present. Okay, and similarly pop of 3, that is it will delete the element at index 3. So index 3 means this is 0, 1, 2, 3. So 23 gets deleted from the list. Okay, after that, after reversing, you will get the result from last element to first element. Okay, so in this case, if you want to modify the element at first index to 100, you can see instead of this 45, you can get the element at 100 in this location too. Okay, this is some of the functions of methods available with list class. Okay, and similarly tuple. So in tuple, I already told it is immutable. That means you cannot able to modify the content. So just I am declaring one tuple and just printing the value. Suppose if I am updating this tuple of 0, that is instead of 30, if I want to replace 35, then what it will give? You can see it will just give an error. You can see that is tuple object does not support item assignment. You cannot able to modify or you cannot able to append. Okay, if you want to modify, you have to change it and assign it to a new tuple. That is the one way you can do it. Okay, and the remaining methods like what we have discussed here, count function, that is also applicable in tuple. For example, if I want to count, then I can write if I want to count how many times 30 is present, you can use the function tuple name dot the method name count with the value. What is the value you are going to count? So I will get 2. Okay, so this is the functions available with tuple, and the next data structure is dictionary. So I'm just moving somewhat little fast because this is the basic thing. When I come to this Numpy and Pandas, you can have a parallel. You can do it also. We will have some slower. Okay. So dictionary can be declared with this within this curly braces I already told. So in that within this you have to specify the key colon followed by the value. Okay, here name colon name is digi, and similarly here the key is roll number and the value is 60 and department is CSE. So you can just print and see. You can see the content of the dictionary here. Okay, and similarly, we are having a number of methods with the dictionary also. I have listed some of the few things. So first one, dictionary.keys. So this function is used to list out the keys present in the dictionary. It will list out the keys alone. You can see dict_keys, name, roll number, and department. And similarly, dict.values. Okay, so it will give the values present in the dictionary. Okay, suppose if you want to retrieve both the key and value, then you can use a function called dictionary.items. This items function will return the dictionary key as well as value. This is the output of this items. Okay, and similarly, dictionary is a mutable one. That is, you can add some another key value pair, or you can delete anything. So we can delete with the help of the function pop. So dictionary.pop of, we have to specify the particular key value. So here I am giving the key value as department. So now I am giving print of dict1. You can see the department key value pair gets deleted from this dictionary. And similarly, if you want to add new key value pair, you can use the function called update. So pop function is for deletion, deleting a particular key value pair. Update function is used to add a new key value pair into the dictionary. So dict1.update of branch CAC. So after that, I am displaying, you see, the name, roll number, and branch. Okay, and similarly, if you want to retrieve a particular value for a given key, suppose if I want to find out what is the value present in a particular key called name. Okay, so in that case, I can use a function called get. So dictionary.get of the particular key value, that is name. So automatically it will return the corresponding value for the key name. Okay, and suppose if you want to modify a value for a particular, if you want, for example, if you want to add new key value pair, I already told one function update, and similar to update, you can directly write like this also. So dictionary within square bracket, you have to specify the key. So I'm adding a new key value pair section, some value as A. So you have to write like this, dict1 of section that is equal to A. This is one way for adding new key value pair into the dictionary, and this is another one way. You can use either update function, or you can directly write dictionary within the index. You have to specify the key. So for the case of list and tuple, index should be numbers, that is from 0 to n-1. Okay, but in the case of dictionary, the indexing should be of key value. So indexing should be of key. Okay, so dictionary 1 of roll number. If you want to suppose modify your roll number, that is also you can do. So see here, you can do it. Dictionary 1 of roll number, that is equal to some 40. Now we can print and check whether it has modified or not. You can see it. Now you can see instead of this roll number 60, I have changed this roll number to 40. So in this way, you can update already existing data, or you can add new key value pair into the dictionary. Okay, so these are some of the operations you can do with dictionary. And the last data structure is set. You see, set is declared within this curly braces. It's like dictionary, like a dictionary, but it is not a key value pair. Okay, so within this curly braces, you can specify any number of elements. So the elements can be of different types, not only a single type. So here I am giving apple, banana, cherry, all the things are strings, but this is not the case. Okay, you can have any data type specified within this. Okay, so you can see print my set, you can get the values. You can see here I am giving apple is 2 times. So I already told set does not allow any duplicate values. So it will remove one apple and automatically take only 1 time. So apple, banana, cherry. Apple is present only 1 time here. Okay, and similarly, you have to add some other elements into this set. You can use a function called add. My set dot add of the new value to be added. Here I am writing this is orange. So after printing this, you can see the orange, apple, banana, and cherry is present here. Okay, so normal set operations like difference, unions, set, superset, and all the things you can do with this set. Okay, so you can see we are having 2 sets X and Y. can find the difference between the two sets using the function x dot difference of y. So x is first set dot difference with second set y. So that is the result is it. If you print and see, it will find the difference. So from the first set, it will remove the common elements and it will print banana and cherry as the answer for this difference function. Okay, and similarly, if you can do union operations also. So x dot union of y. So it will combine the elements from this two set and it will remove the repetition. Duplicates are removed. So you will get banana, Google, Microsoft, Apple and cherry. So and one more thing, set is an unordered elements. So you cannot able to assure or access the element based on the index. So what we have did with the list and tuple, the element at index 0 is this. Like that, we cannot able to get the element from set. Okay, this is an unordered. So I cannot access the element by using this indexing. Okay, suppose then how can I print this? I can use this for loop to get the value and print it. Using loops, you can retrieve the element. Okay. And another thing, x dot pop. Pop function is that it will remove. So from this x, it will randomly delete. We are not specifying anything to delete. So just we are giving x dot pop, and automatically it will delete one value and it returns. What is the element it has deleted from this set? That is written here. Okay, so this is the thing with this Python basics. That is, I have discussed some of the Python data structures which are essential for this machine learning processing. Okay, now we will move on to this Python packages which are needed for this ML. So 1 second, I will share my presentation. So the next thing is the packages essential for ML. So these are the packages which are essential for this machine learning processing. First one is Numpy, and this is for numerical operations. Okay, and Pandas is for data analysis purpose, and Scikit-learn, this supports most of the machine learning algorithms, and Matplotlib is for visualization purpose. We can use this. Okay, so in this session we will see the first three packages, and in tomorrow's session we can see this visualization process. Okay, so first we will start with this Numpy. So Numpy is nothing but it is a numerical Python. This is the core library for scientific computing. Okay, so already we have discussed what is list. So similar to this list, but it is the dimension can be n dimension. It is not only for a one dimensional or two dimensional array. It can have n number of dimensions. Okay, so such a powerful thing. It is for computing. This Numpy provides n number of functions and methods to process with our large volume of data. Okay, in the uses we can see it is used for doing fundamental scientific computations in machine learning, and it is performing mathematical and logical operations, and it provides very useful features for operations are n arrays and matrices in Python. For a simple two-dimensional array, we can go with this list. That's enough. But when we move on with this more than two-dimensional, Numpy is the best thing for processing. Okay. So how to install this Numpy? If you have either Anaconda or Python ideally with your machine, then you can go to this terminal. If you are having Anaconda, then you have to give the command called conda install Numpy. Okay. Otherwise, if you have with your Python ideally, you can open your command prompt and you can just type the command pip install Numpy. This is for using with your own machines. Suppose if you are working with Google Colab, then these things are not necessary. Okay, so because it is already installed with this Google Colab notebooks, we can just import. Okay, so the major things with this Numpy is arrays. Okay, so the Numpy arrays is simply a grid that contain values of same type. That is the one thing already we know In C and other languages, array consists of same type of elements. In a similar manner, NumPy's array is also a grid that contain values of the same type. Okay. And this is the examples. This is a one-dimensional array. Okay. And in case of two-dimensional array, we can have this axis value. The axis 0 represents each row. Suppose if you want to process anything in row by row, you have to specify the axis is 0. Okay, if you want to process in column by column, you can give the axis value as 1. Some of the operations need to specify in which axis you have to do this. Like this, you have to specify. Okay, so in three-dimensional array, you can similarly you can have this row as column 0 and the row as axis 0, axis 1 as the column, and axis 2 as the another dimension. Similarly, you can have n-dimensional array also. We can process with this NumPy in an easier way. Okay. So how to use this NumPy in your Jupyter notebook is have to give the command called import NumPy as NP. As NP is for our easy representation. Okay, so we are giving a name to this. Okay, so if you are not giving import NumPy alone, if you are giving every time you have to specify NumPy dot function, NumPy dot function. So for that we have to give this as rename. So NumPy can be renamed as NP. Okay, so in all the remaining things we can use this just NP dot function name. That's enough. Okay, so this is the line. First you have to give in a Jupyter notebook. And so in NumPy, how can we creating this array? That is the next lesson. Okay, so we are having a number of ways to initialize the new NumPy array. So some of them are listed here. So first thing is we can use the Python list or tuple. So already we are having some list of values. From that list of values, you can create your NumPy array. Okay, that is one option. And another one thing, you can using functions that are dedicated to generating NumPy. For example, we are having a special functions called arrange, linear space. These functions are specifically designed for generating this NumPy array. So you can use these functions to generate the NumPy array. Or we can get the data from files. We can read the data which is stored in the files and we can get this NumPy array. So these are some of the ways. Okay, so I will give a demo how to create this NumPy arrays. Okay, so this is the first thing. Already we are having a list called my list. All the examples given here are minimum one-dimensional or two-dimensional only. So actual processing of NumPy it is for processing n-dimensional array in a faster manner. That is what we are going with this NumPy instead of our list and nested list and all the things. So but for our example, I am given here with this simple examples. Okay, so first thing is we have to pass the list to create a vector. That is my list is equal to I am giving 1, 2, 3 as my element. So I can create an array using NumPy np dot array. This is the function np dot array of. You have to specify the list, my list. Now we can print this axis. You can see this is the thing. So in our list, it will just give this 1, 2, 3. But here you can see this is an array of 1, 2, 3. When you check this type of this X, you can see that this belongs to NumPy array. This is not a list. This belongs to NumPy array. I will show you the things. And similarly, if you want to create a multi-dimensional array, you can pass nested list. That is, you can see here. You can see this is a 7, 8, 9 is one list. Okay, and 10, 11, 12 is another list. That is a list within a list. Okay, this is a nested list. So when you pass this, you can see the first 7, 8, 9 comes as a first row and 10, 11, 12 comes as the second row. So the order of this the rank is here. This is a size. That is the shape is 2, 3. That is 2 rows with 3 columns. This is the shape. Okay. And so these are the some of the NumPy attributes. Okay. So you can find out what is the dimension or what is the rank using the function nd array. In the sense here you can see we are creating the arrays m and x. So that is here given as nd array. So m dot ndim, that is number of dimension. If you give this, you can find what is the dimension of your given array. And shape gives it is a form of tuple of integers indicating the number of rows and number of columns. If your array has 2 rows and 3 columns, it will give us 2, 3. Okay, this is shape. And size gives the total number of elements present in the array. Suppose 2 rows, 3 columns, in the sense 6 elements. That is given by size. And D type, so this defines the type of elements present in the array. Okay, so the data types may be either boolean, character, integer, int 8, int 16, int 32, 64, and all the things are available. So you can find out what is the type of element present in the given array using this D type. Okay, so we'll show the Colab files. You can see here. So the first thing here is I have imported. So import number. So I'm having the function a dot shape. Okay. So now just I'm executing this code. You can see. So the shape here is 3 comma. So what is the meaning? That is only it is a one dimensional. So it will just give this 3 comma. Okay. And this is the number of elements. Can see what is the dimension. I can give the function a dot end. You can see the dimension here is 1. Okay, suppose if you want to find out how many elements are present there, you can write a dot size. You can see the number of elements present is 3. Okay, and if you want to find out what is the type of element present here, you can write a dot b type. So it will print. What is the element present here? 6. Integer. Okay. Suppose if I am giving this as a float. You can see this is the float data. Okay. So these are the properties what I have discussed. Shape, n dimensional. What is the dimension? Okay. Next is size. That gives the number of elements present in the array and data type of the element. Okay, this is just example for one dimensional array. Suppose you can create an array with a 2 dimensional. So this is example for 3D. Just a minute, I will make it as a 2 dimensional array. So you can see this is 1, 2 is one list and 3, 4 is another list. It is enclosed again within another list. Okay, so now we can see this. You can see the shape of the array is 2 cross 2. There is 1, 2, 3, 4. 2 rows, 2 columns. So 2 cross 2, and I'm just printing this B. Okay, so when you are printing, you can see 1, 2, 3, 4. Okay, you can just practice this. Just import, open a new notebook and just type this command, import numpy as np, and you just create a one dimensional array. A is equal to np dot array of, can give some numbers and you can check this properties, what other properties you are getting. And similarly, instead of this single list, you can add another one list here. So this should be enclosed within the list. So you have to give another one list. Okay. So now check it. You can see this difference. It is a 2 cross 3. 2 rows with 3 elements. So total number of elements is 6. Dimension is 2 and data type is float. You can see this output. Okay. So you can just try. I will give some 2 minutes time. You can try with this. Whether you are all trying. This is the way for creating a Numpy array from the existing list. Okay, suppose if you give it as a single list, you can get a single dimensional array. If you give as a nested list, you can get it as a two-dimensional or three-dimensional array. Okay, so okay, shall I move to the next one? Whether you are clear with this or you need some more explanation of this. Okay, I hope you are all doing. So I will proceed to the next one. Okay, so these are the same things, examples, and here you can see the shape. Shape is already I told. For single dimension you can get is 3, and two dimensional if it is 3, 2, and for 3 dimension. So in this case you can see there are 3 cross 2. There is 3 rows and 2 columns, and another one dimension is there. So 2, 3, 2. Similarly, you can create n number of elements. Okay, and another thing, suppose if you want to create, for example, if you want to calculate some image processing functions or anything, if you want to do, you have to create a matrix with all ones or all zeros or diagonal matrix like that. You have to create. So for that, we are having the function calls ones, zeros, full, and right. So zeros, that is np dot zeros of 2, 3. If we give this, you have to create a matrix of size 2, 3 with all zeros. You can see the output is this 2 rows and 3 columns. All are filled with zeros. That is the first thing. So you can see this is the zeros function. Okay, and similarly, if you want to create a matrix with all ones, okay, so if you want to create a matrix with all ones, you can use this function. You can see here. That is np dot ones. Now I want to create a matrix of size 3, 2, 2. So you can see we will get the output as this. It is a 3-dimensional matrix. So everything is filled with, that is 2 cross 2. So that will be given as a 3 times. That is a third dimension. So all the things are filled with 1, 1, 1. If you give dot zeros, everything is filled with 0. If you give ones, everything is filled with ones. Okay. And similarly, if you want to make a Numpy with 0, so you can see here np dot zeros of 10, data type is int. So in that case, you can see it is filled with all zeros. Okay, so this is the answer for this. I'll show you. So it will generate 10 elements. Okay, here I am not specifying the I am giving only 10. That is 10 number of zeros it is generated. So, but in the previous case, I am giving the shape of the matrix. That is 2 rows, 3 columns like that I have specified. But in this case, I am just giving only 10. So it will generate 10 zeros. So I can give the data type also. Suppose if I am giving float, then it will take as 0.0. That will be given here. Okay. And similarly, if you want to create a np dot zeros of 10, 10, 10, 10, 10. So this is the shape is 10 cross 10 cross 10 cross 10. You can see. This is this large size matrix is here. So I'm just not printing here. So I'm just giving the shape. So this shape of the matrix is, it's a 5-dimensional matrix. So 10, 10, all are 10. All dimensions are in size 10. Okay. And similarly, you can use the matrix. You can use the function called full. So you can see the output here. So this fill function is filling the given shape of the array. That is, the shape is 3 cross 5, 3 rows, 5 columns. Everything should be filled with a given value. Suppose if I am giving some other value like 100, so everything will be filled with 100. Okay, so full method is used to fill the particular given matrix with a given value. So the 3 cross 5 matrix is filled with the value 100. Everything is filled with 100. Okay, and similarly, another one function is that is I. This is for creating an identity matrix. Okay, so np dot I of 3, in the sense it will create a 3 cross 3 matrix. Okay, so with the diagonal element is 1. You can see here it is a 3 cross 3 matrix. The diagonals are filled with 1. This is the function of I matrix, EYE function. Okay, so are you clear? Zeros is to generate a matrix with all the zeros, and full function is if you want to give a particular value to all the elements, you can use this full function. If you want to create an identity matrix, you can use the function called EYE. Okay, is it clear? So these are the functions to generate a matrix by default. Okay, and the next thing is we can generate our own Numpy arrays using the function called np.arrange. np.arrange. So the arguments are here: starting value, stopping value, and step size. Okay, so this will create a Numpy array with evenly spaced numbers between the starting and stop with a given step size. Okay, starting value is included and the stop value gets exclusive. Okay, with a given step size. So for example, you can see here np.arrange of 0, 30, 2. That is, we can start at value 0 and we have to move up to 30. 30 is not included. Okay, so we have to step size set as 3. So 2. Suppose if I am not giving the step size, it is an optional. Okay, so automatically it is given us 0, 1, 2, 3 up to 29. It's not included 30, so 29. Suppose if I want to make us a step size 2, I can give this here. np.arrange of 0 is starting value, 30 ending value, 2 is the step size. You can see the output gets changed. Suppose even if I am given here 5, that is also working. So 0, 5, 10, 15, 20 and 25. This is the output of this np.arrange function. Okay. Suppose if you can see here, if you are giving only one number, if I am giving just 5 alone, then it will take default from 0 up to this will take it as the last value. So 0 to 5. So 5 is not included. You can specify the data type also. If I want to create a floating point array, then I can write d type equal to np.float. Okay, so you can see print of n. You can get this. This is a function for generating a NP array using the function arrange. Okay, so the parameters are starting value, optional stopping, optional step size. So that it is given within square bracket. So these two things are optional. Okay, and similar to this arrange function, another one function is that linspace. You can see here. Yeah, this is the given here. So the linspace function works like this arrange function, but there is one difference. That is, instead of defining the step size, I am giving the number of elements in the interval. So here the third argument is not the step size. It is the number of elements you can generate between this given starting and stop value. So you can see the output here. So within 0 to 4, I need to generate 9 elements. So it will generate the 9 evenly spaced values from 0 to 4. So within 0 to 4, it will generate numbers. So 0, 0.5, 1, 1.5, 2, 2.5. So suppose if I am giving some 12 numbers, so you can see it will take values accordingly. 0, 0.36, like this it will take. Okay. Numbers within this range. So obviously it will take 0 and 0.4. Okay, so are you clear with this? What is the difference between arrange and linspace? So arrange, we are giving starting value, stopping value and step size. So how many step size we have to take? to take the values. But in linspace, you have to specify how many elements you have to generate between the given starting and stop value. So between 0 to 4, I need to generate 8 numbers. So the numbers generated are 0, 0.5, 1.14, 1.7 like this. Okay. So this is the thing with linspace and arrange function in Numpy. Okay. So these things will automatically generate values for a Numpy array. Okay. And similarly, we can generate our Numpy array as a random one. You can see here we are having random functions. Okay. So have you tried with this linspace and arrange function? So linspace, you have to give 3 arguments: start value, stop value, and number of elements to be generated. Okay. Same manner, np dot arrange of start value, stop value, and step size. That is the thing with this linspace function and arrange function in Numpy. You can try this so that you can find out the difference between the two functions. Next, we will move with this random functions, so which will generate the values for our Numpy arrays in a random manner. Okay, so for random generation, we are having the function called randint. So that is, we can have the package Numpy. So in that, we are having a package called random, that is for random number generation. So in that, we are having the function called randint. So this randint will generate a random numbers. Okay, so you can see randint, that is within 10 it will generate a random numbers. From 0 to 10 it will generate a numbers randomly. That is, we are giving the size, how many elements we have to generate. So you can see this. So the numbers generated are, this is 0 to 10. Within 10 it will generate a number 8, 3, 7, 7. Okay, so you can see here now 42522 is answer. Suppose if I am running it again, you can see you will get some other numbers. So every time if you are giving, it will give a different numbers. But in case in some of our machine learning projects, we want to generate with some random numbers, but we have to, suppose if you are doing either prediction or a prediction task, for example, have to get your input as a random one, but every time you have to get the same random numbers. For example, if you want to increase the number of iterations, first time you are executing the model design with some 10 iterations, the next time you have to execute with some 20 iterations, but all the iterations, the input should be same. So in that case, you have to use the function call, that is np.random.seed of 100. Seed number may be anything, if you take it as seed 0 or anything. So in that case, if you see here, how many times I'm executing, I'm getting the same number, 503379. If I'm executing it again also, I'm getting the same number. You can see the difference. So initially I have made it as a comment line because I'm not setting any seed value. Now you can execute this and see we are getting 352476. If I'm executing again, you will get some other numbers. If you execute again and again, you may get some random numbers. Numbers are getting generating randomly. But if you set this seed value as some value, so now you can see it is executed. So 503379. If I've executed again also, it will generate the same random numbers. Okay, so this function is useful when you are doing your same experiment for the same data, for the same set of random numbers, but if you want to increase the number of iterations, or you can modify some parameters and do it again. So in that cases, you can use this random.seed function. Okay. And similarly, if you want to make it as a 2-dimensional also, you can generate. So 3, so size is 6 means it is a 1-dimensional, 3, 4 means it is a 2-dimensional. You can see the numbers are written. Okay, so this is one of the random function for generating a Numpy array randomly. Okay, suppose if I am giving it as 100, then you can get some other values within this 100. Okay, so this is one of the function for generating a Numpy. Okay, and another main thing is Numpy array is also similar to list indexing. So how we are indexing list? We are using the index value starting from 0 to total number of elements minus 1. Suppose if you are having 5 elements, the index starts from 0 to 4. So similarly, the same indexing is used with this Numpy also. You can see here, this is the x1. Suppose if you want to access the element at index 0, then you can use this x1 of 0. Suppose access the fifth element, you can write 4. Negative indexing also possible. So in this, from left to right, you can have the index 0, 1, 2, 3, 4 like that. If you want to index from right to left, we can have this negative indexing. That is, this is -1, -2, -3, -4, -5, -6. So negative indexing also possible. You can access it. Okay. So second last way, if you need, then you can write x1 of -2. Okay. So this is simple for one-dimensional. Suppose if you are moving the two-dimensional array like this, you can see it is a 3x4 matrix. Okay, so here if you want to access the first row and second column, that is first row and second column, you can write like this x2 of 2, 3. So this is for accessing. So this is for accessing third row and fourth column. This is for accessing last element, that is third row and fourth column, that is x2 of 2, 3. So 0, 1, this is full 0 and this is 1 and this is 2. So in this row, how to access the third element, that is 0, 1, 2, 3. So I'm getting the answer is 0. And similarly here you can mix both positive and negative index, that's also working. For example, if you write x2 of 2, -1, that is you are accessing second row, that is the thing, this is 0th row, first row and second row. Okay, second row -1 indicates the last element, so you will get 0. Okay, so if you want, you can access like this, and similarly you can replace. Suppose if I want to change the value 3 to 12, then you can write x2 of 0, 0. That is 0, 0 means this value. That is I have modified into 12. Instead of 3, I am giving it as a 12. Okay, so just now you can print and see what are all the values you will get. So instead of 3, you can get the value as 12. So this is the way you can access the element present in the Numpy array. Okay, so if it is a single dimension, single indexing is enough. If it is a two-dimensional array, then you have to specify the row value and column value. So just keep in mind, everything will start with 0. So whether it may be row index or column index, everything will start with 0 and it end with n-1. That is the indexing value. Suppose if you want to replace, that is also possible. You have to give the indexing value at the left side and the newly assigned value is given in the right side. Okay, so this is the accessing value. And similarly, slicing. This is also possible. So slicing in the sense, if you want to get a set of values. So here accessing 0, 0 means you are retrieving single element. Suppose if you want to retrieve one full row or one full column, like this if you want to retrieve, you can use this slicing. So slicing is the array name. Within square bracket, you have to specify starting value, stop value, step size. Okay, starting value, stop value, step size. Okay, so if you are simply giving 2 colon alone, so the meaning here is you can start with 0. You are moving till length of s. That is, what is the length of the array? So last value and step size is by default 1. That is the slicing notation given here. Okay, so you can see here, this is just an example. So you are generating a Numpy array using arrange function. So the values are 0 to 9 printed. Suppose if you give a colon, that means you are extracting the entire list. If you write print of a colon, you will get the output as like this. Suppose A 1 colon means you will start with this index 1. So you will get the data from 1 to 9. Suppose if you give 1 colon 3, start with the index 1 and 2. The stop value is excluded. It is not included, it is excluded. So 1, 2 is there. So 1 colon minus 1 means starting from this first index till minus 1. So minus 1 in the sense the last element is excluded. That is the minus 1 index. So that is excluded. So you will get the output as this. Okay. And similarly, if you do colon colon. So colon colon in the sense you are not specifying the starting value and stopping value. You are just giving the step size. So if you are not specifying starting, it will take from 0. If you are not giving end value, it will take till the end of the array. So 0, step size is 2 means 2 gets incremented. So 0 to 468. Similarly, if you want to take it from 1, you can specify 1. Suppose if I am giving colon colon minus 1, it gets reversed. So I am taking the data in the reverse from the last. So 9876 543210. So in this also you can give the step size also negative. So step size negative in the sense it will take from back side, that is right side, it will take the values. Okay, so these are all almost you are familiar with this list. In list also they are doing the same type of slicing. But in Numpy array we can come with this. If you come with this 2-dimensional array, just a minute and share. Yeah. You can see in 2-dimensional array, you have to specify the two things. Already we have seen indexing, that is row value, column value. Similarly, if you want to slice a 2-dimensional array, then we can give this slicing operator also here. For example, if you want to extract only this two numbers, 10 and 20. So how you have to specify? For the row, you have to specify starting to 1. That is, I can able to access only the 0th row. So what is the meaning of colon 1? That is only 0th row, and colon 2 means 0, 1. That is 2 columns I can take. So this is your 0th row, and this is your first row, this is your second row. Okay, so in this 0th row, this is the 0th column, first column, second column. Similarly, 0th column, first column, second column, then 0, 1, 2. So if you see like this, colon 1, that means you are accessing only this row. This row alone I am taking. So from this row I am taking only 0 and 1. So it returns 10, 20. Suppose if you write like this, colon 2, that means you are taking this row and this row. These 2 rows it will take, and 1 colon means starting with 1, moving to n. So 1 in the sense you are taking this 20 and 30, and similarly here also from first index I am taking 50, 60. So you will get the output is 20, 30 and 50, 60. Similarly, if you give colon 2, what is the meaning here? So I am taking from 0th row to first row. So 0, 1 row, and similarly here also column is also 0, 1. So you can see in the first row and second row, you are taking the first column and second column. So 10, 20 and 40, 50 I am getting. Okay, so similar to indexing, we can do this slicing also using this colon operator. So if you want to specify, you can specify 1 colon 2. That is also possible. If you want to here given step size, that is also you can do. But this is a small array, so we are not giving specific. We are not giving this step size here. Okay. So the next thing is, one second I will show. Okay, so the next thing is we can do this concatenation. Suppose if you want to combine any 2 arrays with the same size, you can see here x is also, it's a 1-dimensional, and y is also 1-dimensional, and z is also 1-dimensional. Okay, suppose if I want to concatenate all the 3 things, I can use the function called np.concatenate. Within it, you have to make it as a list, so you have to write within this x, y, z. So you can see here. So this 3 arrays are concatenated, and it is made as a single list, single array. So that is 1, 2, 3, 3, 2, 1, followed by 21, 21, 21. Okay, so you can use the function called concatenate. Okay, similarly, the next thing is you can, if you want to concatenate either row wise or column wise, we can specify. So here we are not specifying anything. So automatically by default it is concatenated in row wise. Suppose if you want to concatenate in column wise, you have to specify the axis. Axis equal to 1. You can see here. So this is the grid array, that is 1, 2, 3, 4, 5, 6. So these two values are concatenated with axis is 0. That is, you can see 1, 2, 3, 4, 5, 6. That is the first array, and 1, 2, 3, 4, 5, 6 is the second array. That is concatenated. Okay, row wise. Suppose if you want to do it as a column wise, then you can give this axis is equal to 1. You can see the difference here. So this 1, 2, 3 is concatenated with 1, 2, 3, and 4, 5, 6 is concatenated with 4, 5, 6. That is, it is added in column wise. So first row is added with the first row, and second row is added with the second row. That is column wise, it is concatenated. This is one of the function. If you want to concatenate two arrays either in column wise or row wise, we can do it with the help of the function called concatenate. Okay, so this is one thing. Another one main thing is we can suppose if you want to combine a two-dimensional array with one-dimensional array. Here you can see here all the arrays are of same size. We can use concatenate, but you can see here X is a one-dimensional array and grid is it's a two-dimensional array. Suppose if you want to concatenate this two array, what you have to do is can use either VStack, vertical stack function, or horizontal stack function. You can use any one of this. Okay. Suppose if you want to do vertical stack, then you can see the output here is this 3, 4, 5 is there. So it is vertically arranged. There is row by 1, 2, 3 followed by 17, 18, 19. Okay. So hex stack means it is horizontally. So 1, 2, 3, 17, 18, 19 is the grid. So in that we have to add this Z matrix, that is 9, 19. So it is horizontally stacked. So for each row, one number is added. Okay, suppose if you want to combine an array with two different sizes. So in that case, instead of concatenation, you can use a function called VStack and HexStack. Okay, so this is some of the glimpses of this Numpy functions. Okay, so whatever functions you need, these are all needed while doing pre-processing for your machine learning algorithms. Suppose if you want to make a random number for your weights, for example, if you do with deep learning or neural network related things, if you want to make a weights as a random weight, so in that case you can use this random weight function. Or else if you have some two arrays, you can concatenate either using this concatenate or VStack and stack. Any function you need, you can refer from this Numpy methods. Are you clear with this Numpy methods? Does anybody have any doubts? Yeah, yes sir, I will share the notebooks also to the organizers, they will share with you. And so next we will move on to this Pandas. You can see Pandas is a Python data analysis library. Okay, so still now we have generated some arrays. With the help of Numpy, we can generate array or we can do any operations with the large volume of data with the help of this Numpy functions. So next thing is, we have set of data, we need to do some analysis. So in that case, we can use the package called Pandas. So Pandas is a Python package for doing data analysis. Okay, so what are the main things with this Pandas is series and data frame. So the two main data structures with the Pandas is, one is series. Okay, series is nothing but it is like a one-dimensional array. And second thing is data frame. So data frame is like a two-dimensional. Okay, so how can we create this series? We are having this already Numpy array. You can see this code. So just like import, you can write this import Pandas as PD. Okay, for renaming we are giving PD. So data equal to having one Numpy array with the value ABC. So from this Numpy array, I am going to generate a Pandas series. So how can I generate this? So I'm giving some name series S is equal to PD dot series of this data. I'm passing this numpy array as an input to this pandas, and I'm getting this print of s. So you can see here, so it is always indexed. As I can see here, now when you are seeing with numpy array, we are getting only the elements A, B, C, D, or 1, 2, 3. But in this case, you can see the series, you will get another one column, that is 0, 1, 2, 3. This is added by itself. This is an indexing. By default, index start with 0. Okay, so we are having 4 elements, so the index start with 0, 1, 2, 3. Okay, suppose if you want to specify your own index, so I don't like the 0, 1, 2, 3, I need to give my own indexing, then that is also possible. You can write a function pd.series of data, comma index. What is the index value you have to give for this data, that you can specify with this index. So index equal to 100, 101, 102, 103. Okay, so 100 A, B, C, D. So now instead of 0, 1, 2, 3, you can see 100. What are the index value we are giving? That will be added here. So what is the data type? Here the data type is object. That is a given here. So the Pandas series data type is object. Okay. Then the next thing is, suppose we can directly give the list also, and we can index, no need for number. Index can be also be a strings also. You can see here. Suppose if I want to print. Now you can see the elements are 1, 2, 3, 4, 5. Indexing is A, B, C, D. Okay. So how can I access the element from this data frame or series? So in our Numpy, we are getting the index, by default index start with 0, I told you. But here you can use this index. So suppose if we are not specifying index, in the first case we saw, it has automatically generated 0, 1, 2, 3. If not, if we are giving any specific index like 100 or like A, B, C, D, E, then you have to retrieve the element with this series name within square bracket. You have to give the index value. So index may be here A, B, C, D. In this case, you can take the index may be 100, 101. Like this, you have to specify to retrieve a particular element from this series. Okay, and this is a Pandas series. The second one is Pandas data frame. So data frame is it is like a row and column. You can see here. So this is the series. Okay, so data frame is a 2-dimensional array with heterogeneous data. You can see series is a 1-dimensional array with homogeneous data. It is similar to a column. Column that all the things will be of same type. But data frame is it's like a 2-dimensional array. That is, it is a consist of multiple rows and columns. It can have heterogeneous data. For example, first row may be your register number, second row may be your name, third row may be your department, and last row may be marks. Like this, you can specify. So this is the data structure in Pandas. Third one is panel object. This is dictionary of data frames. Like you can see, this is a sheet in MS Excel. So you can see multiple sheets are there, and similarly, this panel object is a dictionary of data frame. It is a collection of data frames. Okay. So this is the example for creating a data frame from list. We are having a list called data, and we have to create a data frame using the function pd.dataframe. So the previous case we have discussed pd.series for creating a series. Now you can see pd.dataframe of data. So now you can see this. For each row, we are generating index, and for column also, it will give an index value. Okay, you can see here, this is also 0. But in the previous case, this indexing is not present. Only this row-wise indexing is there. Okay, suppose this is from list. If you want to create a from list of list, that is nested list. If you want to create a data frame from a nested list, you can use this. That is, we are giving Alex 10, Bob 12, Clark 30. So in that case, we can create pd.dataframe data. Suppose if you want to give name to a particular column, that is, first column is named with name, second column is named with age. If you want, you can specify with the attribute columns equal to name, age. Suppose if you are not giving, you can see it is given as 0, 1. Suppose if you want to give your own name, you can write with this columns equal to. If you give like this, the columns are named with a given name and age. This is the way for creating a data frame from nested list. Similarly, you can create your data frame from dictionary also. So you can see, so name is the key, set of values we can give, and similarly age is the key. We are having some 4 values. So from this data frame, dictionary, you can create a data frame, pd.data frame of data. Okay, so print df. Now you can see in this dictionary what are all the keys that will be taken as the column name. So name, Tom, Jack, Steve, Ricky, and age is another column. The values are taken as corresponding things. Is it clear? So in this way also you can create a data frame from dictionary, and similarly you can see here, this is another one example. So here A is 1, B is 2, and it's A is 5, B10, C20. Suppose if you're creating like this, what are all the columns here? Column is A and B. That is available in 2 things, but C is another one thing is here. So C is present, but in the first dictionary you see there is no value for C. So in that case it will be taken as not a value, NaN, not a number, that will be taken as input. Suppose a particular corresponding for a particular column there is no data is present, then it will be taken as a NaN, not a number, that will be taken. Okay, so these are the different ways to create a data frame. So these are just for examples, but most of us we are working with the data set. So if you have a very large Excel file, a CSV file, so from that file we want to access our data. Okay, so that data will be given to any machine learning algorithms or deep learning algorithms. So in that case, Pandas is providing functions with like this. Okay. So you can have the function called read CSV. Suppose if I want to read some CSV file, okay, I can use the function called pd.readCSV. Okay, so in that functions, you can read this entire CSV file using the function called reads_CSV. Okay, so in Google Colab, how you have to take this file? Suppose if this file is available in your local machine, then what you have to do is you have to write this 2 lines. Okay, so from google.colab import files. Okay, so next thing is files.upload. If you give this command and execute, it will be ask you to choose a file. You can take a file from your local machine. You can see, just I'm clicking choose file. So it will open a dialog box. From this I can take my required file. So just I want to take a file. I'm taking this cars.csv. Just click open. Now you can see it is uploaded. That is, it is stored here. Okay, so this is the way, this is one of the way you can import your files from your local machine. Or else if you put it in your Google Drive, that also you can take it. Okay, so you can see how to import any type of file you can import. Not only for CSV file, you can take any image file for processing or any text file for processing. Anything you can upload from your local machine to the Google Colab using this 2 line of commands. Just I am posting here, you can take it. So you can use this 2 line of commands to upload your files from your local machine to Google Colab environment. Okay, so this is the way. So suppose if you want to check what is the file uploaded and what are the contents, you can just verify with this variable. That is uploaded. Just check with this variable. You can see what is the name of the file, and next thing is what are the columns present. So you can see this data set have 28 columns. Okay, so manufacturer, model, this contains information about this cars. Manufacturer, model, type, fuel tank capacity, passenger length, with all the things are available. So that information you can check with this. Okay, so next thing is, so just we have up to this point, we have just uploaded the file from our local machine to Google Column. Next thing is, we need to read this file. Okay, so we have to read the CSV file and store it as a data frame using the function pd.readcsv. So within this, you have to specify the CSV file name. Okay, suppose if you are working with your local machine, that is, for example, if you work with your IDLE or Anaconda, then you can specify your path URL directly here. There is no need of such things. These things are only for upload your file to Google Column. Okay, so read CSV, you have to specify the full pathway. You can just take the data. So it will be stored as a data frame. Okay, so now I can check what is the shape of this data frame. I can check with this data frame name dot shape. So 93,28 indicates totally 93 rows with 28 columns. This is rows and columns. Okay, and the next thing is, you can just view what are all the information present in the data set. Okay, so for that you can use a function called info. So df1.info. So in this you can see what is the class. This is the data frame. So pandas.codeframe.data frame. So range index is 93 entries. That is 0 to 92, and totally 28 columns. Okay, then what are the columns? Okay, so first column is 0, then manufacturer, model, what is the non-null count, how many non-null values are present, 93. Okay, and similarly you can see here some of the values are null, that is 91, 82. That means some values are missing. Okay, and the last thing is data type. So some of them may be integer, object, float. Okay, so what is the type of a particular column? You can check it. Okay, so this is the information available with .info. Okay, and the next thing is, if you want to view the number of column names. Suppose if you want to retrieve only the column names, you can use the function dataframe.columns. If you want to get the data type alone, so you can write df1.dtypes. Dtypes is used to retrieve the column. So this is the output for this column, list of column names. Okay, and the second one, dtype, for each column what is the data type. That is also, these are just for your information. What is the data present in the data set? We have imported one Excel file or CSV file. So we need to view what are all the content it is present here. Okay, so another thing is, what is the dimension? It is a 2-dimensional. Okay, and these are all the information about your data set. Okay, suppose if you want to view the data present in the data set, what are the informations present? You can view with the help of the function called head. So df1.head of 10. Okay, so 1 second, I will share the link of this data set, then you can practice with this. So I'm just sharing this link. You can take this data and you can process it. Okay. Okay. So this head function is used to view the elements present in the first 10 rows. If you are not specifying any value, you can see you will get the first 5 rows by default. Okay, suppose if you want to see the number of rows, then you can specify the count. So you can see this 20 rows are output. Okay, and similarly, if you want to see the last 5 rows, then you can use the function called tail. From the bottom of your data set, if you want to view some of the rows, by default it will give 5. If you change the number, you will get that number of rows. Okay, so this head and tail function is to view the data present in the data set. Okay, and suppose this is the entire, that is the entire 28 columns are displayed. Suppose if you want to view only some of the columns, then what you have to do is you have to make it as a separate data frame. So we are having the data frame df1. So from that data frame, I need to take only this manufacturer and model. 2 columns alone I need to take. So what you have to do is pd the data frame. So from the original data frame df1, the columns manufacturer and model, the two columns I need. Then you can write a statement like this. Then you can see only these 2 columns are presented, the data frame df. Okay, suppose if you want to see some 5 columns, you can specify. What are all the columns name you have to specify, that will be extracted and store it as a separate data frame. Okay. Another one main thing is the function called describe. Data frame dot describe. So what is the function of this function? What is the work of this function is, this function will give the, for each column, it will give how many elements are present. If there is any null value, that will be removed. So that is the count. What is the mean value of the set of values present in the particular column? What is the standard deviation? What is the minimum value? What is the maximum? And all the things you can view with the help of this function describe. So df1 dot describe. Participants, kindly unmute your mic.
Hi everyone, this is Python Guru. You are watching the Audacity software.
Sir. Go ahead and answer.
Yes, ma'am.
Can you unmute your the particular person's mic?
Yes, ma'am.
Okay, sir. Thank you, sir. Thank you, sir. So this information you can view with the help of this function describe. Okay, so count, mean, standard deviation, and minimum. And this is only for this field which is data types is int, float, and all the things. That things alone you can see here. Suppose if a particular data type is object, particular column data type is object, so that information is not present here. So if you want to view the statistical property of a particular column which data type is object, then you have to specify like this. That is describe include equal to np dot object. Okay, so that is the object data types. Okay, so for which columns the data type is object, you can view the count, unique value, top value, and frequency. This 4 information alone you can see. That is object type means it will have some string values. So if the column consists of string value, then obviously you cannot able to find what is the mean, standard deviation, minimum, maximum. So that is why that columns are skipped from this describe. Suppose if you want to see the particular statistical property for this column also, you have to write like this, include equal to np dot object. So if you write like this, for the particular column, it will give the count, unique values, top and frequent values it will show. Okay. And another one main function. So this data analysis, this Pandas is mainly at the starting stage. Before pre-processing, we can visualize our data set. That is how it is present, how many null values are there. If it is null value, how can you replace? All the things we can do with the help of this Pandas. So another one function is you can see how many unique values are present. Okay, so for example, manufacturer is one of the column, so it will have different companies, Ford, Chevrolet, Hyundai, and all the things. So for each manufacturer, how many values are present, we can count. Use a function value underscore counts. Okay, so for each company, how many entries are present in the data set, we can identify with the help of the function called value underscore counts. Okay, and if you want to calculate particular mean for a particular column, you can do. So the data frame name within square bracket, you have to specify the column name dot mean. Similarly, you can find minimum, maximum, standard deviation, all the things you can do. Okay, so you can see DF min dot price dot maximum, in the sense you can see what is the maximum value. Similarly, you can get this minimum. All the functions are available. Suppose if you want to analyze a particular column, what is the minimum value, what is the mean, and all the things you can do with this help of these functions, min, max, and mean. Okay, and another one main thing I want to convey here is, suppose how to replace this null value present in your data set. Okay, so the first thing you can identify, is there any null value present in the data set or not. Okay, that is done with the help of this function. DF, that is data frame dot is null function. If you see, if you give this, you can find a matrix data like this. So what are all the values are not null, that will be given as false. That is the data present is given as false. If there is any null value, that field alone given as true. Okay, so if you do like this, you cannot able to easily find out how many null values are present there. So for that, we can use a function called isNull.sum. That is, the sum function will give how many null values are present in each column. You can see here, in the column manufacturer, there is no null value. And similarly, you can see only this rear seat room. In this column alone, we are having 2 null values. Okay, so this function is dot sum. This function is used to find how many null values present in each columns. Okay, so next thing, how can you treat this null value? So you can see in this rear seat room row column, we are having 2 null values. There are 2 options. One is we can either drop the particular row. If it is null value, we can drop the row, or else we have to fill the null value with some value. Okay, so there are 2 options we can do. Just I will show one thing. You can just give this data frame dot drop NA. Okay, so we are having the function called drop NA. So what it will do is, it will replace all the null value, sorry, it will discard the row which is having null value. Suppose if we are having null value in 2 rows, that 2 rows will be removed. Okay, so after doing this, you can check this rear seat room. That is also, there is no null value 0. Okay, so this is one way. But suppose if your data set have more number of null values, then this is not the best option. For example, if you are having some 1000 rows, in that there is some 100 missing values, then you cannot able to discard all the 100 rows. Then what you have to do is, you can imputation. We can say that is data imputation. That is, we can replace this null value with either the frequently occurring data. For example, in a particular row, repeatedly coming, then you can replace with full. Or the best option is, you can take the mean of the available values. So we can take the mean and we have to replace the null value with the mean value. That is, we can do. For example, you can see this is another one column, that is lucky room. Just 1 second. Now you can see I have refreshed the data. So lucky room in the column also, we are having 11 data as missing value. So what we are going to do is, we have to take the mean. So I am taking only that column, that is luggage room column as alone, and in that column I have to find the mean value. Okay, so for the particular column I have to take the mean value and I am filling the null value with the mean. For example, you see the function d dot fill a of m comma in place equal to true. So what is the meaning of this in place equal to true? So actually it will change the data present in the data set. So if I'm not giving in place equal to true, it will just fill with the average value and it is displayed to me. That's one. So after this, if you are doing the next operation, these null values are not properly handled. Okay, so you have to use the argument in place equal to true, which will make the modification permanent in your data set. Okay, so you can use the function fill either drop NA, that is drop the rows, or you can use the function fill NA with the mean value. This is one way. I can take the mean value, or else if you take any frequently occurring value, that value can be replaced with this. So that option is with yours. Okay, how to analyze your data set based on the values which is occurring more frequently, or you can take the average and replace with this null value. Okay, so now you can check after doing in place equal to true, you can check that you will get the values as 0. There is no null values available. Okay, so these are some of the pre-processing steps. Okay, so after loading your data set, you can visualize and you can see what are the properties, what is the statistical properties, what are the columns available, is there any null value, if there is null value, how you can treat all the things, you can do that with this pandas. Okay, and this is up to this pandas. The last one thing I want to convey is just I'm giving this overview. This time is almost over, so just I'm sharing the things with the scikit-learn. So this is one of the open source Python library that implements a range of machine learning, pre-processing, cross-validation and visualization algorithms in a unified interface. That is, it provides most of the machine learning algorithms in a single line. That is, everything is predefined. We can just use the machine learning algorithms with the proper arguments, we can implement our model. Okay, so this model is mainly focused on model building. The model may be classification, regression, or classification. So similarly, you can install the scikit. If you are using your IDLE or Python Anaconda, you can install with the help of this pip install function. And so just I'm taking this example of k-neighbors classifier. In the morning session itself, Sat told what is the functioning of this k-neighbors classifier, and just giving a sample code. How can you do with this scikit-learn package? Okay, so in the scikit-learn package, you have to import the necessary packages. So from sklearn, you can import neighbors. This is for doing knn function, and we can import data sets. In scikit-learn package itself, it will have some set of predefined data sets. From this data set, we can take any data set for doing and pre-processing. This is for pre-process our data set. That is, we can do some normalization and all the things. And the next one, sklearn.model selection. We can take this test train split. That is, when we are designing our model, usually we have suppose we are having 100 rows of data as our data set, we have to take it as a sum of the data as test value and sum of the data as training value. Maximum we are taking is 80-20 or 60-40 anything. So we have to divide the data into training and testing split using the function. Automatically it will divide the data. Okay. And this is for finding out the accuracy. At the last, after designing our model, you have to find out this accuracy using this method. Okay, I'm taking this iris dataset, which is already available with this scikit-learn package. So I can just open this datasets.load_iris. So it will automatically load the dataset into this data frame iris. So in this dataset, I am taking this. Almost you are all familiar with this iris dataset. If not, I am telling it is for flower dataset. So we are having 4 features: petal with petal length and sepal with sepal length. 4 features are there. Fifth column is the classification, which category this flower belongs to. Okay, so we are taking only 2 columns, that is petal length and petal width as our x value, and the target is y. That is the last column. Which classification, class A, B, C, it belongs to. 3 classes are there. So in that classes value will be stored in y. So X is the feature. Okay, we are taking 2 columns as our input feature and we are taking the target. Okay, so this is X and Y classification. Next, we can use the function train test split. So I'm just giving the overview. So remaining all the functions will be in detail explained in the corresponding next hands-on session. I'm just giving one simple example. Okay, so test train split function, what it will do is it will take the X and Y data and it will randomly divide the data into training set and testing set. Suppose if I'm having 150 data, 80% of data will be taken into training and remaining 20% will be considered as a testing set. That is done with this train test split function. Okay. After that, if you want to do pre-processing, you can use this. I'm doing a standard scalar function. That is, my values are 1 value is 10, 1 value is 5. Like that, the data is present. So I'm doing this scaling functions based on the mean and standard deviation. Okay. So this is the standard function available. So in that scalar function, I'm using the scalar function to transform my training data and testing data. Okay, using the function scalar.transform xtrain and scalar.transform of test. So testing and training data both are scaled to the value which is around to this mean and standard deviation. Okay. So after this, you can create your model with a single line. That is neighbors classifier. Neighbors classifier. So within this, you have to specify how many neighbor points you have to take. So I am taking this neighbor point as 5. Okay, you can see here. So for example, the green dot is my newly data, which I am going to predict. It belongs to either blue color square or red color triangle. That is the thing I am going to predict. Suppose if I am taking my neighbor size is 3, you can take this solid circle. I'm taking my neighbors is 3. So in this, you can count the red color triangle is 2. So what it means, my data may belongs to this category. Okay, suppose if I'm taking my neighbors is 5, take the dotted circle. So we are having 5 neighbors. So among these 5 neighbors, 3 belongs to this blue color square. So there is a possibility that my data may belongs to this blue color square. That is the task of this neighbors classifier. Okay, so you have to specify how many neighbors you can take. Okay, we are taking 5 neighbors. You can modify and check it how much accuracy you are getting. Okay, so this is the code for create your model. Okay, so now I have created the model called KNN. Next, in that model, I am going to fit my data. That is, I am going to train. Okay, so KNN.fit xtrain, ytrain. Now I am training my model using the function fit. After training, what I have to do? I have to check whether my model is working properly or not. Okay, so for that I am using this model evaluation. Okay, so KNN.predict. While predicting, I am giving this X test data set as input. So X test. So it will give some Y prediction. That is, a particular flower may belongs to class A, class B, or class C. That thing it will give. That is stored in this Y prediction. Okay. Finally, I am calculating this accuracy score based on this Y test and Y prediction. Y test in the sense, actual value of this test value. Okay. Y prediction is the calculated value from my model. So both of this will be compared and I am finding out the accuracy score. So this is the very simple model for KNN classifier I'm giving. So you can see you will get the output is just I am showing the output. You can get the output accuracy like this 57.89. I am giving this neighbors is 5. So I can modify this. Okay. Suppose you can initially I told I am taking only 2 columns, that is petal width and petal length. You can take 4, that is 4 features are available. So you can take this 4 features and you have to train and execute your model. You may get your accuracy in terms of 87 something. So this 57 is for taking only 2 features. If you take 4 features as your input, okay, then you will get more accuracy. Okay, so this is one example for using this KNN classifier. So almost all the functions are available. Just you need to know how it works and what are the parameters we can give. How can we tune our model? That is the thing we need to see. Okay. So this is up to this. And these are some of the references I have taken. And that's all. Thank you. Whether you have any doubts among this Python packages, you can ask. So whether anybody have any doubts, you can just ask me. So these are the packages, but this Pandas as well as scikit-learn have n number of functions. Okay. So once again, I will show the references. I will post here also. So there are some cheat sheets are available. So where you can view all of the mostly available functions for each Pandas and Numpy, scikit-learn also. We are having the cheat sheets. So which contains most of the frequently used functions available there. Okay. Whether anybody have any doubts, sir? Okay. Go my name, sir.
Yes, ma'am.
Sir, session. I have finished my session, sir.
Okay. Thank you, ma'am. Thank you very much, ma'am. So, any questions from participants? Yes, sir. We will share the content as well as Google Meet link also we will share to you, sir. Participants, already we have posted the Google Meet feedback link. Feedback link already we have shared. Please kindly fill the feedback. Once you fill the feedback, you can leave.
Thank you, participants. Thank you for your patient listening. Thank you all. Thank you, Goman and sir.
Thank you very much, ma'am.
Thank you, sir.
This is some things that I need to not do. Do not have any just a minute, sir. I will share it.